One of the basic ideas in section 10.6 is that there's a new thing we can do to both sides of an equal sign, to both sides of an equation. And that is, we can take the left-hand side and multiply it by itself as many times as we want, as long as we take the right-hand side and multiply it by itself the same number of times. So how do I know how many times I want to multiply each side by itself? Well, it depends on what the pieces are. I know that I would like 2 of these, because the square root of x times the square root of x is x. That's the central fact. So I'm going to multiply both sides by themselves twice. This will give me x equals 9. I must check in the original, and putting a 9 in here gives the square root of 9 is 3, and that is true. So 9 is the answer. Note, before you go further, I recommend doing this. There is another way of writing it, and I think you should reserve this for when you're really good at it. And that is, you can square both sides. But squaring both sides is the same thing as multiplying it by itself. And this squaring both sides, yeah, the square root of x squared is x, and yes, 3 squared is 9, but you lose something when you do this. You lose some understanding. So I strongly recommend you do this first, and only resort to this when you need to save space. It's a bad idea on this problem to square both sides right away. You want to try to get the root by itself. So we can add 4 to both sides because the 4 and the 1 are not inside the square root sign. Now we can multiply each side by itself. Take the left-hand side and multiply it by itself, or take this to the second power and take the right-hand side and multiply it by itself, or take this to the second power. The reason we're doing that is because we can look ahead and see this times itself is going to be y plus 5 is 25. Subtracting 5 from both sides, we have y equals 20. There's a mandatory check, so we go back to the original problem and we put a 20 right there. So we're going to have the square root of 20 plus 5 minus 4 is supposed to equal 1. That's the square root of 25 minus 4 is supposed to equal 1. That's true because 5 take away 4 is 1. So 20 is the solution to this problem. A number of problems like the first one we just did, it's time maybe to step up your game just a little. How many fourth roots does it take multiplied together to give you the thing inside, in this case t minus 10? The answer is it would take 4 of them, so we could multiply this by itself 4 times and multiply this by itself 4 times. But we could instead write it this way, and with 4 of them, this saves a significant amount of time. 3 to the 4th power is 3 times 3 times 3 times 3, or 9 times 9, or 81. This, multiplied by itself 4 times, gives you exactly the thing inside. Adding 10 to both sides, we get t equals 91. Now that needs to be checked, and so we check it in the original equation. In place of t, we put 91, and we ask ourselves, is this true? No, we have the 4th root of 81 is supposed to be 3. Is it true that 3 times 3 times 3 times 3 is 81? And yes, it's true, it checks. So t equals 91, and we're done. So I want to multiply each side by itself 2 times, or I could square each side. But multiplying 2 of them isn't too hard. So I'm going to practice what I preach, which is writing these pieces down every chance I get. Because one thing that's doing is it's helping remember the key fact that a square root times itself gives you exactly the thing inside. Square root times itself gives you exactly the thing inside. I'm going to take away 3 x's from both sides, and that'll put the x here. But then I'm going to add 1 to both sides, and that'll put the 3 here. And so I'm thinking x equals 3 is the solution. If I put 3 here, I get the square root of 11 on this side. If I put the 3 here, I get the square root of 11 on this side, so that checks. So 3 is really the solution. So here we're going to have a little bit of a problem. I'm going to subtract this from both sides of the equation so that I have the square root of x plus 2 equals 2 minus this square root. Then I'm going to multiply each side by itself. I'm squaring both sides in essence. On the left-hand side, really nice things are going to happen. On the right-hand side, some fairly unpleasant stuff is going to happen. Here we get x plus 2, which is just really nice. Here we get a 4. And then we get minus 2 of these square roots, minus 2 more of them. That's minus 4 of those square roots. And then we get a negative times a negative, which is a positive, and this square root times itself is the thing inside. So the left-hand side was pretty nice, the right-hand side not so nice. Collecting some like terms, we have 4 plus 4 being 8. We have plus a 3x, and we have a minus 4 times this remaining square root. Taking away 3x from both sides, taking away 8 from both sides, I now have on the right-hand side this, and on the left-hand side this. I can, if I want to, and I sort of want to, divide every single side by 2, so this gets divided by 2, this gets divided by 2. That'll give me a minus x, and then minus 3 equals, and that's negative 2 times 3x plus 4. So I'm going to multiply this side times itself, not because I want to, but I need to get rid of this square root on the right hand side, so I guess I should put a square root in. And on the left hand side, doing FOIL or whatever, I'm going to have x squared, and then I'm going to have plus 6x, and then I'm going to have plus 9 equals, and on this side I get negative 2 times negative 2, which is 4, and then I get times 3x plus 4. 3x plus 4. So distributing on the right hand side, I get 4 times 3x, which is 12x, and 4 times 4, which is 16. Taking away 12x's from both sides and taking away 16 from both sides, I get x squared minus 6x minus 7 equals 0. I'm going to solve this by factoring and setting each factor equal to 0. I'll get x minus 7 times x plus 1. I'm getting x minus 7 equals 0, or x equals 7, or x plus 1 equals 0, or x equals negative 1. Now these two solutions need to be checked. If I put in 7 into the original problem, what I get is the square root of 9 plus the square root of 25 equals 2, and that's false. If I put in negative, so that's not a solution. If I put in negative 1, I get the square root of 1 plus the square root of 1 equals 2, and that's true. So negative 1 is the only solution to the original equation, and I'm done.